The periodic table of the elements is made of 7 horizontal rows, 18 vertical groups, and 118 squares, each belonging to one element. The element's atomic number is at the top of each square, and it shows its place in the list from lightest to heaviest. Another number, called the atomic weight, is often shown at the bottom of each square. This lesson explains what atomic weight means and how it's different from the atomic number. We'll start with a down-to-earth example to illustrate this. Imagine you're making a soccer team. How could you line up your team to give each player his or her own number? One way is alphabetically. Then who would be number 1 and who would be number 11? Aisha would be number 1 and Zara would be number 11. What are other ways of lining up? How about by height? Then Barry would be number 1 and Parvez would be number 11. What are other ways? We could use weight. Going from lightest to heaviest, who should come first? Zara is the lightest, so she's first. She needs to swap with Barry. Can you see any other changes that need to be made? Madeline is also lighter than Taj, so she has to come in front of him. Now all the weights are going from lightest to heaviest. This list is almost the same as shortest to tallest, which makes sense because people usually get heavier when they get taller. But not always. Going from lightest on the left to heaviest on the right, Zara is number 1 and Parvez is still number 11. We can now see 2 rows of numbers, the player numbers at the top and the player weights at the bottom. The size of both increase going from left to right. How are they different? Notice that the player numbers are always whole numbers because they show the player's place in the list. You can come second or third in a list, but can you come second and a half? No. But the players' weights are measurements that can have fractions and decimals. So what have player numbers and player weights got to do with the atoms on the periodic table? Well, if each soccer player were a different kind of atom, we'd give each a symbol with 1 or 2 letters. And then line them up from lightest to heaviest, just like the players. The player numbers of the soccer team are like atomic numbers, and their player weights are like the atomic weights, except of course on a much bigger scale. In the next videos, we'll change our soccer team to an atom team and look at a much smaller scale. An atom is 1,000 trillion times lighter than a soccer player.